We're going to continue to look at functions, but today we're going to focus more on the graphs of functions. We really have two types of categories of functions, even functions and odd functions. At the right over here are two examples of even functions. Even functions are symmetrical about the y-axis, meaning on each side of your y-axis it's the mirror image of the other one. So here, if you're 1 unit to the left of the y-axis, you've got to have a matching point over here, 1 unit to the right. Or similarly over here. Here you're 3 units to the left, here you got to have its corresponding point over there, 3 units to the right. In other words, if you have a point over here, that's x over and y up, you got to have its corresponding point over here, but instead of being x over, it's x to the left, so that means it's a negative. So in other words, for an even function, you have a negative x and a positive y. In other words, if you go ahead and substitute a negative x into your original function, if it simplifies down to give you your original function, then it's an even function. We also have an odd function. Odd functions are symmetrical about the origin, which means if you would take the origin right here, rotate this part right here 180 degrees about this point, so don't move that point, but just take this, rotate it 180 degrees, it will give you this function up here. Same idea with this one. Here's your origin. If you would take this, rotate it 180 degrees, it would give you this one over here. So in other words, if you have a point here of an x, y, you got to have its corresponding point over here, which instead of being x units to the right, you're x units to the left. Instead of being y units up, you're y units down. So in other words, if you have an xy, you got to have the corresponding point negative x, negative y. Basically, if you put in a negative x again, and it simplifies down to be the opposite of your original function, then it's an odd function. Now, most functions are not odd and not even. They're neither. But a few functions are even and a few functions are odd. Once again, here's the rules of what you need to do to check. So in other words, if you're trying to check to see if it's an even or odd function, you got to plug in a negative x either way. So you go ahead and you plug in a negative x. Then you want to simplify it. A negative to an odd power changes the sign in front. A negative to an odd power changes the sign in front. Negative to an odd power changes the sign in front. And so you'll notice that this right here is really the opposite of what we started with, because you'll notice all the signs of our original are switched down here. Since it's the opposite of the original, it is an odd function. We would say it's not even because it did not simplify down to give us exactly what we started out with for our original function. Just as a quick review, if you're adding after your function, it moves it up 2 units. If you're subtracting after your function, it moves it down 2 units. If you're adding before you apply your function, it moves it left 2 units. If you're subtracting before you apply your function, it moves it right 2 units. If you are multiplying after you get done with doing your function of the squaring, then it makes it twice as tall, so it's a vertical stretch of 2, or multiplying afterwards here would be a vertical stretch of a half. But here, you're multiplying before you apply your function. It affects it horizontally just like it was up here, because you were doing stuff before you did your function. So it ends up making it half as wide, so a horizontal stretch of a half. Or here, with your half being multiplied, it's going to make it twice as wide, so a horizontal stretch of 2. Here we have what's referred to as a piecewise. We have 3 different pieces, 3 different rules we need to follow to be able to graph this. All I'm going to do is look at this in 3 pieces. Here it says if you choose any value less than or equal to negative 2 for your x, you got to use the top rule. So I chose some values for negative or for x that fit that rule of being smaller than or equal to negative 2. Plug negative 2 into here. Plug negative 3 into your rule. Plug negative 4 into your rule. And then you can go ahead and plot those points. Plotting our points of a -2, -5, -2, -3, -2 or 4, -7. And then you connect those and you get this. Now notice it starts here and goes to the left because once again this says once you get to x being -2 you never want to go to the right of that. So that's why my line stops here because here's my -2. I can't go to the right of that. Let's take a look at the bottom one. Bottom one says when you choose anything larger than a 1 for your x, you got to use this rule right here. So I chose some values greater than -1. Take, or not -1, +1. Take a 1 and plug it in. We get 3. Take a 2, plug it in. Take a 3, plug it in. Plot those points. Then draw in your line and you get this. Now once again it says you can't go to the left of 1 for your x. So that's why my line goes here and goes out to the right forever because it says it can greater than 1, which is going out to the right forever, but it stops here once my x becomes 1. In between a -2 and a 1, it says I got to use this rule. So I chose some values in between -2 and 1, and I plug them in. And then all we're going to do is just plot those points. Now, technically, according to this, there's no equal to, so I can't really use a -2, but it really does tell me where to go ahead and draw my open circle. Same idea here with my 1. I can't technically use it, but it tells me where to draw my open circle for the ends of that graph. And so then I would get a graph that looks like this. Now, you could go ahead and graph a piecewise function on your calculator. This would be the notation you'd have to use to be able to graph it on your calculator. You would get your inequality signs from second math, which is your test. You'd also get your and from second math, but arrow to the right once you go second math. Well, let's take a look at this graph at the right. What would happen to my graph over here if it says f of x plus 2? Well, remember, adding 2 in your parentheses moves your graph 2 units to the left. So I just moved this whole graph 2 units to the left, and then that would be all. Here, if it just said f of x minus 3, that just, remember, subtracting after your function just moves it down. So it's going to take my whole original graph, move everything 3 units down. Remember, multiplying your function by something just doubles it. So in other words, it's going to make it twice as tall, so it's going to double all my y values. So this point here would be at 0, 8. This one here would be at 1 up to a height of 2. It's not going to double my height here because my height here is 0. Same idea. It's going to move this one up to 2. It's going to move this one straight up to 8 because it's going to double your y values. Here, half of x. Remember we said that makes it twice as wide. So you're going to have to multiply all your x coordinates here by 2. So this x coordinate won't change. This one here, multiply the x by 2, it would move it over to here. Multiply this x by 2, it would move your point to here. Multiply this x by 2, it would move over to 6 up 1. This one here, it would move it over to 8, but up 4. This one here, if you were given this point and you were told to do this, remember multiplying your function by 2 doubles the y value. And then it says you got to move it 4 units up. Well, if you got to double the y value and then move it 4 units up, you're not doing anything to your x. But it says you got to double your y value. Your y value was -1, so you got to double it. Moving it 4 units up changes your y value, so you got to add to your y value. So you get the new point of a 3, 2. This is a step function. In other words, it doesn't allow you to get any decimals out. It rounds it down. So what would this one do? Well, remember this moves it right 3. That's a vertical stretch of 2, and that moves it up 1.